So today's learning objective is to solve problems involving direct and inverse proportion, including graphical and algebraic representation. Understand that x is inversely proportional to y is equivalent to saying x is proportional to 1 over y. Construct and interpret equations that describe direct and inverse proportion. Okay, so a lot in there, but basically, let's just start off with introducing what the idea of proportionality is. So, okay, proportionality. And proportionality is basically when you have, say two numbers, and the ratio between them is always the same. So say you have kind of numbers, say like x and y, and if x is 1, y is 4. Or if say x is 2, y is 8. If x is 4, y is 16, for example. And if we look at the ratio between y and x, y over x is equal to here, 4 divided by 1, which is 4. If we look at here, it's equal to 8 divided by 2, which is also 4. And again, if we look at the final case, y over x is equal to 16 divided by 4, which is also 4. And as we can see, the ratio between y and x, i.e. y over x, is always the same. It's always 4. And if you were to say, for example, calculate x over y instead for the ratio, y is equal to, again, 1 divided by 4, so that's a quarter. But, if we had 2 divided by 8, which is again a quarter. And the same thing happens with 4 over 16. X over y is equal to 4 over 16, which is a quarter again. So that's what we mean by proportionality. That the ratio between the two numbers that we have is always the same for kind of each value of, say, for x and each value of y. If we look at, say, another example, for example, say we had something like a and b, or not a and b, let's say, I don't know, p and q. We haven't used p and q yet. So p and q. So if we had, say, if p is 1, q is 3. If p is, say, 2, q is 6. If p is, say, 10, q is perhaps, say, 32. And if we look at, say, if these two are proportional, we can do, find the ratio between p and q. So p over q is equal to, for the first one, 1 over 3. Well, let's actually do q over p, because we'll get, whole numbers. So q over p is equal to the ratio 3 over 1, which is 3. Q over p is 6 over 2 for the second one, so that's 6 over 2, which is also 3, but if we look at the final one, it's q over p is 32 over 10, which is 3.2, which does not equal 3. So this is not, here p and q are not proportional, because the ratio is not the same for all values. Here it's the same for all values, but here, for this last value, the proportion actually changes compared to these two. Sorry, the ratio changes. So this means that they're not proportional. And now you're thinking, how might we actually represent that on, say, a graph? Or actually, let's think about how we might represent proportionality algebraically. Well, we know for all values of y and x, right, that y over x equals some constant ratio. Let's call that k. So that's another way of saying that is y is equal to kx. I'm just rearranging the above here. So if we times both sides by x, we just have y equals kx. And that's an algebraic representation of proportionality. That means that the ratio between y and x is always k for all values of y and x. And how might we represent this? Well, we know we can represent this on a graph, right? This is just a straight line through the origin with the gradient k. Ooh. So let me try that properly. And that's all it is. This is the line y equals kx, and the gradient is k. So this is a graphical representation of proportionality. So if I was to say, for example, let me give you an example of two things that might be proportional. Say, we have a car, right, and it goes at constant speed of, say, 20 miles per hour. Jeremy uses 400 grams of flour to make 88 muffins. How much flour would he need to make 30 muffins? Well, let's think about, say, kind of how much flour it takes per muffin, right? So per muffin, it will take, if we have 400 grams of, well, actually, let's write this down. Say, flour per muffin. Well, the flour per muffin ratio, right, we can kind of assume that stays constant, right? Because, if whenever you're cooking, right, if you need to double the recipe, for example, you just kind of add twice as many ingredients. So flour per muffin ratio, we kind of know that stays constant. And we know what the flour to muffin ratio here is. We know that's, for example, let's just say that stays constant. And if we know, so for example, it takes 400 grams of flour to make 88 muffins, and we know this ratio should equal the same for, say, the flour needed, so let's say F, to make 30 muffins. So let F be the flour needed for 30 muffins. We know this should be true because the flour per muffin thing should be constant. And if we just multiply both sides by 30, well, on the right this cancels out, and then on the left we're left with F is equal to 400 divided by 88 times by 30, which is 136 grams. Rounded 136.4 grams, rounded to 1 decimal point. So this makes us use the fact of proportionality that that the flour to muffin ratio will be kind of the same or always be constant. And another way of saying that is that flour is proportional to muffins, right? And the sign we have is this: flour is proportional to muffin. That's the sign that means proportional. Like a fish, but they're, I guess, swimming to the left. But that's what this sign means. It means flour is proportional to muffins. Okay. Now that we've talked a bit about what proportionality is, we should talk about what inverse proportionality is. So inverse proportionality is, so for example, with proportionality we have saying the ratio of x to y is some constant rate term, which is what we say, for example, k. So i.e. x is ky, for example. Or we can say that x is proportional to y. For inverse proportionality, what we have is the ratio of x to 1 over y is the same, is constant for every term. So for example, if I had, say, some x and y like this, I say x and y, so if x is, say, 1, y is a half. If x is a half, y is a 2. If x is, sorry, that was wrong actually, if x is 2, y is a quarter. If x is, say, 4, y is a eighth, for example. And if we see here that the ratio of, and now if we can draw another one, 1 over y, we have 2, 1 over 4, 1 divided by 1 over 4 is 4, 1 divided by 1 over 8 is just 8. And now we can see that the ratio between 1 over y and x is the same, is a constant, so it's a kind of 1 over y divided by x is equal to 2, and then 1 over y divided by x is equal to 4 divided by 2, which is 2, and then 8 divided by 4, which is also 2. So this is what inversely proportional means. So that the ratio of x to 1 over y is some constant. And that means if x is, so the question here is, say, if x is inversely proportional to y, then it's the same as saying x is proportional to 1 over y, which is what we've said here, right? If x is inversely proportional to y, then x is proportional to 1 over y. That's basically what inverse proportionality is. And now we have to kind of construct and interpret equations. So when you're kind of constructing equations, right, what you usually want to get some sort of algebra, right? So either you have something like this, where you just say you have one unknown and you have a ratio, so you solve it like I've talked about here. Or another case, more generally, what you might want to do is say, if you have two things, if you have x is proportional to y somehow, whatever x and y are, you can form an equation saying x is equal, or actually let's say y is proportional to x. Y is proportional to x, which is the same thing as saying x is proportional to y, but this is just more a standard way of saying it. Well, you can write this as y over x is some constant k, right? Because that's literally what the definition of proportionality is. And that means y equals to kx. And you can find the value of k by kind of, if they give you two values, and you can find what the value of k is, and that applies to kind of all the values of y and x, and then you can just solve the equation like that. If we do kind of a bit of a harder one here, 3 teachers can mark 9 exam papers in 10 minutes. How many exam papers can 10 teachers mark in 20 minutes? So now we've kind of, we've increased the number of time and the number of teachers. So we know, what you call it, that, the proportion of kind of the teachers, number of teachers to number of papers marked is going to be some sort of proportional constant, right? So if we say that so we know, for example, that, and also we know, say, kind of the number of time as well, right, is going to be proportional as well. So if we kind of, time is also going to be proportional to the number of papers marked. So we know we have some sort of ratio right now, proportionality-wise, of 3 teachers to 9 exam papers to 10 minutes. And we know that this is going to be kind of, this is kind of true, basically. This is the information we have from the first sentence. And as I said before, we know that the teachers is proportional to paper, and time is also proportional to paper, right? Number of papers marked. So this is a 2-step problem. So let's say, if the question was, if this was just saying 10 minutes, right? So if 3 teachers can mark 9 exam papers, we know kind of that, let's say number of teachers over number of paper marked is some constant k, right? We know that's going to be the same. So we know 3, so k is equal to 3 over 9. So k is equal to a third. And so if it was 10 teachers, 10 over p is equal to a third. So p, if we kind of rearrange this, is equal to 30. So basically, another way of thinking about this is saying, if 3 teachers can mark 9 exam papers in 10 minutes, how many can 1 teacher mark in 10 minutes? Well, 1 teacher can mark 3, so if there's 3 teachers and they mark 9, so that means 3 each, right? So 1 teacher can mark 3 papers in 10 minutes. And now we have a question of saying in 20 minutes, right? So, well, in 20 minutes, they can just do the double, so that's just 2 10 minutes, right? So 1 teacher would mark 6 in 10 minutes. So if P is that, so, the number of papers marked by 10 teachers is 30 in 10 minutes, it must be 60 in 20 minutes. That's kind of how you do a question like that. I've got another one here. A ball falls vertically after being dropped. The ball falls a distance of d meters in the time of t seconds. D is directly proportional to the square of t. So this is a bit different. We've got the proportional to the square of t, not just proportional to t. The ball falls 37.8 meters in 3 seconds. Find the formula for d in terms of t. Okay, so we know that d is proportional to t squared. And another way of saying this, remember, is saying d is equal to k t squared. And we can plug this number in here. We know that, say, when t is equal to 3, d is equal to 37.8. So 37.8 is equal to k times 3 squared. So k is equal to, using the calculator, 37.8 divided by 9, 4.2. So the formula we have is that d is equal to 4.2 t squared. Calculate the distance the ball falls in 18 seconds. Well, now we've got this formula, we just have to kind of plug the number in. So when t is equal to 18, d will equal to 4.2 times by 18 squared. Using a calculator, 1,360.8 meters. And then c is calculate the time taken for the ball to fall to, So again, this is just plugging in the formula. We know this is true. So 2625 is equal to 4.2 t squared. Just rearranging, we get t is equal to 2625 divided by 4.2, and then we take the square root of that, which is 25. So t is equal to 25 seconds. And that's how you do a question like that. So just as a quick recap, what we do, first line, we use the information we have. We say kind of d is proportional to whatever, or x is somehow proportional to y, whatever we have. And then we use that to formulate an equation like this. If, for example, we were to find out a d is inversely proportional to t squared, for example, we'd have d is inversely proportional to t squared, which means d is proportional to 1 over t squared. And so we'd write a formula like d is equal to k over t squared. And that's how you'd solve it in this case. So that's basically always your first step, and then you plug in the numbers you have to find what k is, and then after that, kind of, you've got a formula that applies to basically should apply to all situations, unless kind of it explicitly says something changes. If that applies to all situations, then you kind of just work with the part B and part C as should kind of using that formula. So hopefully that all made sense, and I'll see you guys in the next video. Oh, actually, before I completely forgot. If I talked about graphical representation of of proportionality of y is proportional to x. We know y is equal to kx, as I said, and that kind of looks like a straight line, right? But the question is, if y is inversely proportional to x, what does that look like? Well, we know if y is inversely proportional to x, we know y is proportional to 1 over x. We know that kind of thing. So if that's true, then that also means that kind of y is equal to k over x, which is kind of, graphically, if you remember what y over 1 over x y equals 1 over x graph looks like, it looks like something like this. And we'll pass through if, when x is 1, y is k. It passes through that, for example. So, yeah. So that's what an inversely proportional diagram might look like. Whereas a proportional graph would look like this. Yeah, so hopefully that all made sense, and I'll see you guys in the next video.